Okay, so I'm going to start off with some pretty simple graphs. The first one being if I just have r equals something. R equals something, if you think about what r is which ring we were on when we were plotting points. So if I'm always at that same ring, that means I'm just going to have a circle. Okay, so anytime it just says r equals something, just know that's going to be a circle. And then to graph it, you're just going to trace around that ring. So r equals 3, I'm on the third ring out, 1, 2, 3, and it's just going to be that graph. So it's a pretty basic circle. Theta equals something. If I just have theta equals an angle, first of all, you should know where to go to for pi over 3. That's going to be this angle right here. If it says my angle is always pi over 3, this is always just going to be a line. So last time we were talking about the symmetry of the line theta equals pi over 2, and we said that was like the y-axis, right? Theta equals pi over 2 was this line. So theta equals pi over 3, just going to be a line that goes through the terminal point of the angle pi over 3. So those are two really basic ones, pretty easy to graph every time. If we have a circle that's kind of been moved around a little bit, this is kind of just your guide for graphing a circle. Two things that I want you to worry about. Look, you can plot points. You can plot, plug in thetas, meaning the angles. I could plug in the angle 0 and the angle pi over 6 and pi over 4 and pi over 3 and so forth all the way around. You don't want to do that. It takes too much time. So all I'm going to do is say, look at these features. This is what it causes the graph to do, and it's really pretty basic to graph. So is it sine or is it cosine? What that determines is the orientation. Okay, so you might just want to write that down. It determines the orientation. If it's sine, that just means that the circle is going to be oriented along the y-axis, or up and down. And if it's a cosine, it's going to be oriented either to the left or to the right. So since this wasn't a sine, this is going to be an orientation of being up or down. I also know it's up because that 2 is positive. So the a value, which is that number out front, where that 2 is at, that a value is just going to give you the height on the major axis. And what I mean by that is which orientation did you have. So all I'm going to do for this circle r equals 2 sine theta is I'm going to put a point at 0. We're going to always start there. And then I'm just going to go out, since a is 2, I'm just going to go up 2 to the second ring here and put a point there, and I'm just going to have a circle that goes between those 2 points. So when I graph this, I'm just going to go to the middle of those 2. Hopefully yours is a little bit better than that, but that's all we have. And again, if you wanted to plot points and make a table, you could do that, but this is all I really care that you know to do. Okay, the next one's a limacone. A little bit more information we need to worry about here, but again, not going to be extremely difficult. So, first of all, if you look at that front page of those notes, I just kind of want to write this in terms of A and B, because I know all this stuff asks about A and B. The first one is A, the second one is B. So, for this limacone, this would be A plus B cos theta. So the first thing is it cosine or sine? Again, that's going to determine the orientation. And since this one is cosine, that means it's going to be oriented to the right or to the left and not up and down. The ratio of A to B, that is going to determine what type of limacone you have. Is it a cardioid? Is it does it have an inner loop? Is it dimpled? What is it? So I take the ratio of A to B. A is 2, B is 2. So I have that A equals B. And if you look at that front page of those notes, it says what to do based on that ratio of what A is to B. So since A is equal to B, that means it's going to be a cardioid, which means we're going to have one of those heart-shaped kind of graphs here. A plus B, A, and A minus B will all give you other information. A plus B is 4, right? 2 plus 2. And that is going to be the height. Oops, the height on the main axis. Okay, A is just 2. That's going to determine the stretch on opposite axis. Okay, so since this is cosine, I should mention this, since this is cosine, our main axis is going to be the polar axis, or the x-axis, and the opposite axis obviously would be the y-axis here. A minus B is 0. That's going to determine your lower point. Okay, so if we have all that, okay, so since our lower point is at 0, I'm going to go ahead and plot that. I know it's cosine, so it's going to be oriented either to the right or to the left, and again, that's going to be based on positives and negatives. So since this is going to be oriented, since it's positive, it's going to be oriented to the right. The height on the main axis is going to be 4. So I'm going to go to the 4th ring, 1, 2, 3, 4. And then 2 is the stretch on the opposite axis. Don't go this way. So the opposite axis would be the vertical axis, and from the origin, I want to go, or from the pole, I want to go stretch 2 on the opposite axis. So I want to go to the 2nd ring here and here. And again, since I know this is a cardioid, I don't want to do that. I mean, that's going to kind of determine what you do with these points. Really, these are the only points that I want you to have. Again, if you wanted to plot, plug in thetas and figure those more distinct points, you could. But I know it's a cardioid, so I know it's just going to come up and touch there and then go back here and kind of look like a heart. So I'm going to try my best to make something that looks somewhat heart-shaped here. And it would look something like that. Actually, the bottom part here is a lot more accurate than the top part. So it's kind of like a round, circular kind of heart shape. All right, but that's all the information that you need. It's really pretty basic to get those. Okay, next up we have a rose, and how do we graph a rose? Again, just need to find some information here. First of all, the A is the number out front here, and that number with the angle is n. So we have r equals a cosine n theta. How to find it or what it determines, A is going to be the length of the petals. So in this one I know that they have length 4. The number of petals, you got to look at n, and you got to make sure that you see if n is even or odd. That's going to determine some different things. So if n is odd, then you have n petals. It's pretty easy. If n is even, then you have twice that many petals, so 2n petals. So in our case, n is 2. That means that n is even, so we're going to have 4 petals on the graph that we make over here. Where to start the first petal? What you're going to do here is you're going to substitute A for R, and you're going to solve for theta. Whatever that theta is, that's the angle that you're going to start with your first petal. Okay, so what I'm going to do, I'm going to work out how to do that. So A is 4 here, so I'm always just going to take whatever this number is here, and I'm going to replace R with that number. So to find where to start, I'm just going to say 4 equals 4 cosine 2 theta, divide by 4, 1 equals cosine 2 theta. Now remember way back from like chapter 7, I can't divide by 2 because it's inside the cosine function. So the next thing I'm going to have to do is say 2 theta equals wherever cosine is 1. So where is cosine 1? Use your trig sheet, use unit circle. Where is cosine 1? That's going to be at the angle 0. Okay, over here, that's where cosine is 1. Then I can divide by 2, and I get theta equals 0. So where am I going to start? I'm going to start at the angle 0, whether you think of that as 0 degrees or 0 radians, it's up to you, but that's where we're going to start. And then to rotate the petals and how far we should go in our rotation, we're just going to take 360 degrees and we're going to divide by the number of petals that we have. And that's how often we have another petal. So for what we're going to be doing here, we're going to take 360 and we're going to divide by 4 since we have 4 petals, and we're going to get that we have another petal every 90 degrees. Okay, so I'm going to start. I'm always going to put a point there because it's going to be centered there at the pole. I want to start at the angle 0, which is just straight out to the right. The petals have length 4, so I'm just going to go out 1, 2, 3, 4. And then I have another petal every 90 degrees. So I wouldn't draw this petal yet because I really don't know like how skinny or fat I should make the rose petal. So I'm just going to go ahead and put the end points of all the petals first, and then I will do that. Rotate 90 degrees, that's going to be another petal. Rotate 90 degrees, that's going to be another petal. Rotate 90 degrees, that's going to be another petal. I'm going to have 4 petals, which is what we said that we would have here. So then I can go ahead and graph all these petals. I hope you do a better job than what I'm doing. But it should look like that. Okay, so again, pretty basic if you just know what you're looking for. Solving for those things, not going to be too difficult. Okay, the last one that we're going to look at on the notes is a lemniscate. And to graph one of those, it's really going to be pretty easy. Your equation, and I've got those here, is either r squared equals a squared cosine 2 theta or r squared equals a squared sine 2 theta. So what changes is cosine or sine. Everything else is staying the same. If it's cosine, there's symmetry about the pole, the polar axis, and the y-axis, or theta equals pi over 2. And if it's sine, there's just symmetry about the pole. For cosine, all I'm going to get, these are the ones that look like propellers, all I'm going to get is it's going to be along the x-axis, and it's going to go out a distance of a in both directions. And that's all that I really need to know. So that distance is going to be the same there. If I have sine, the first thing I need to do is it's going to be not oriented on the x-axis or the y-axis. It's going to be oriented on the line, and you can think of it a couple different ways. Either the line y equals x, which is this diagonal slope of 1 through the origin, or if you want to think of that as the line theta equals pi over 4. Since we're looking at these polar coordinates, it's just going to be about that. And again, I'm just going to go out a distance in both directions of a, whatever that a value is. The only thing you need to watch for is be really careful, since in the equations it's a squared. So for the one we're going to graph, that 9 means that a is 3. It's sine, so it's going to be oriented along the line theta equals pi over 4. So the first thing I'm going to do, theta equals pi over 4 is our diagonal line right through here. But I'm just going to go out a distance of 3, since A is 3. So 1, 2, 3, and 1, 2, 3. And then we're just going to have our propeller. Some people just want to draw a figure 8, which is what I do most of the time. But it's going to look something like that. So these are really easy because it's just going to be one of these two things every single time, and you just need to determine what A is. Okay, so those are basically all of our graphs that we have. Again, just remember they can take on slightly different shapes. Like for the limosone, I only graphed the cardioid. They can take on different shapes. And there was also, if you go back and look at that front of the notes, there were spirals and things like that. Really, all you really need to know is, if I give you some equation, find what that equation is. Is it R equals A? You know, does it fit one of these? Does it fit one of these or those? You know, and that will determine what your graph is going to be. I know that it seems like a lot at first, but I promise it's not going to be too bad once you start graphing those.